Okay. Okay, so today we are going to do part of, you know what I'm gonna call this one, 32, 3-2D, I think. Me too.
Like this question. This question. And then I should be able to go.
Wait, did you have teacher development yesterday?
Yeah,
Why would they do it yesterday, and not today?
that's a great
And they would
question.
have given us a long weekend, like a little longer weekend.
I almost didn't go to school today, but I have to. Because of state.
Why is the world so annoying?
Can we go for a nice stroll?
Well, we are going to solve quadratics by the quad formula. And then we'll be done. That's it. So it's,
You promise?
yeah,
Pinky promise?
for today,
Cross
yes.
your heart, hope to die. Sticker.
So I just want to recap. When you solve a quadratic,
I just did that.
is when you
Never mind.
find where the parabola crosses the x-axis. Crosses the x-axis. So if you read that whole thing that I wrote out for you on that Monday that I was out, I sort of went through all of this. So you can either have two answers, you could have just one, but you get that answer twice, or it could not cross at all. So those are basically your three different scenarios. Obviously, the parabolas could look all sorts of different ways, but that's the gist. You're either going to have at most two solutions. I take that back. You'll always get two solutions. It's just, are they going to be two different ones? The same answer twice, which means I'm really only hitting the x-axis one time, or I never hit the x-axis. And this is what I just mentioned. Your answers for something like this are going to come out as imaginary numbers. You already know how to solve quadratics. There's multiple different ways to do it. Ways to solve quadratics. You can solve by factoring. That's what you did on Monday. Okay, factor, factor, factor. So if the factor is equal to 0, there's your answers. You can also solve by square rooting. So that's where you don't have a B term, right? We'll look at those in a, yeah, we'll look at a few of those too. So this is where B must be 0.
Deleted.
You can also solve by completing the square. We'll look at that on Monday, but I'm sure you probably remember it from last year. And today we're going to look at using the quadratic formula. So I don't know how much you remember from last year. Do you remember the quadratic formula? Or whenever you took algebra 1, I should say. Do you remember? So I just want to make a note. These last two, completing the square and quad formula, you can do them on every single quadratic, no matter what. Factoring, as you know, some quadratics don't factor. So if they don't factor, that doesn't mean that there's no answer. It just means that it's not going to be integers, right? you're gonna end up with some irrational answer usually. So we can't just factor because that wouldn't get me the answers to all the problems. And you can't always solve by square rooting, obviously, because that's only certain cases where B has to be 0. So B obviously is not always 0. So the last two you can use on any. So I know what you might be thinking. Well, why don't we only do the last two? They're actually pretty cumbersome. And it takes a little, like it's a lot longer to solve a problem using the quadratic formula than it is to just factor it. Factoring is 10,000 times faster. So if it's something that I can factor, I'm gonna factor. But if I can't, I need other tools. And this is one of our heavier hitting tools. So let's write down the quadratic formula in case you forgot. Everybody think they remember? Go ahead, give it a shot.
I just don't remember the denominator. The opposite of B plus or minus square minus 4ac.
Yeah,
I just don't remember the
anybody remember the denominator? It's all over 2a. Yes,
Negative B
there it
plus or
is.
minus a square, B squared minus 4ac. Oh, wait, where's the C?
Oh, I forgot to write it. Sorry, my bad.
I only know it because of the song that like was paid like 5. What?
Yes, okay, thank you. I'm so glad you saw that.
All over to the right. You should play the song.
You should sing it louder so it's on the video.
X is equal to negative B plus
Ray,
or
let's do
minus
our full show
square.
right now.
B squared minus 4ac all over to the right.
Yay.
Everyone go listen. Stream X is equal to negative B plus that song on missing is equal to what? That's how I got something. Remember?
Yeah.
Let's sing it. Everybody that knows it, sing it
What?
loudly. So
5,
it's
6, 7, 8.
Stand out.
X is equal to negative B.
That was just sad.
That is so sad. Only Elisa will know it.
Over to.
You should play it and then everyone will know it.
No, I'm.
so I mean, and that's honestly the hardest part of the quadratic formula is just remembering it. So the song would be very helpful for you to memorize that formula. Because if you mess up one piece of it, then there's no way you're gonna get it right. Okay, so there's the quadratic formula in all of its glory. Make sure, I want to point out a couple of things, because sometimes kids write this part down wrong. The fraction bar has to go all the way across. So it's got to be like this negative b right here has to also be in the numerator. Sometimes kids only put the fraction bar under this, and that's not right. So the fraction bar should go all the way from one side to the other. The other thing that I see as an error sometimes is that sometimes you don't make the square root house long enough, right? It's got to go all the way to the end. It's not just b squared that's under the root, it's everybody all the way to the very end. So make sure that this is long enough and that fraction bar is long enough. Okay, so there it is. If you can pick out A, B, and C from a quadratic, you can solve with the quadratic formula. If you are careful and you don't mess up your signs. So let's start off with a really easy one that actually could be factored, but we're just not going to factor. We're just going to start with something easy. All right. How about, let's see, I'm going to pick, gosh, that one's not very, okay, let's do this one. It's not that bad. All right. So let's say I wanted to solve the following. Let's say I had y equals x squared plus 12x, and then, so that I don't mess this up. Minus 64. So all I have to do is pull out what A, B, and C are, and then pop them into the formula. So what's A? A in this case is 1, right? That's always the coefficient of the x squared, so that's just a 1. What's B? 12, and C is negative 64, right? Mind your signs. So now when I pop it into the formula, let's see how this works out. The formula says, I want negative, let's see if I can get the formula in this at the same time. There we go. Okay, so I'm just gonna follow along. I want negative b, so that's gonna be a negative 12, plus and minus a big old square root. And now I wanna do b squared. So I'll put all the numbers in. I know you know in your head 12 squared is 144, but that's okay. Minus 4 times a in this case is just a 1 times c is a negative 64. See how all those pieces are in there? And then big old denominator, 2 times a would just be 2 times 1. Now, so there's the easy part, just popping all those numbers in. Now you need to evaluate that correctly. So let's go through the steps to make sure that we're not messing up this part right here. All right, you ready? So out in front, I just have that negative 12, plus minus, big old square root. 12 squared is just 144, right? Here's where kids mess up all the time. I can't even tell you how often kids mess up a sign right here. Here is my helpful little hint to you. After the b squared, you'll always have these three numbers. You're just multiplying them together. A negative times a positive times a negative. Isn't that going to be a positive? So it's just going to be, I just got to figure out what 4 times 64 is. It's 256. So that's a positive 256. I can't express to you how many times kids mess up the sign right there. So if drawing this little box helps you and you're just like, oh, let me just multiply those three numbers together, that would be a positive 256. So a plus 256. The bottom is just a 2. And now I just keep evaluating. I got to add 144 and 256 together, and that gets me 400. So now I'm here, negative 12 plus or minus the square root of 400 all over 2. We get lucky this time because the square root of 400 is just 20. So this is now negative 12 plus and minus 20 over 2. You don't leave your answer like this though. You can do this. This means do negative 12 plus 20, which is just 8, right? And then divide it by 2. So one of my answers is just going to be 4. Do you see where that came from? Negative 12 plus 20 is 8. 8 over 2 is 4. Then I go down the bottom row, negative 12 minus 20. Oh, negative 12 minus 20, that would be a negative 32, right? And then I just divide that by 2. So negative 32 over 2, isn't that negative 16? So there, friends, are my two answers. If I were going to graph that parabola, it would cross the x-axis at 4 and at negative 16. Notice the curly brackets. Curly brackets means, hey, here's just a list of my answers. Order doesn't matter. If you put the smooth parentheses, now you're saying it's an ordered pair. That is not what you mean at all. It's not an ordered pair. It's just say, hey, here's all of my answers. One's at 4, one's at negative 16. So that's when life is easy and you end up with a perfect square right here. That's not always going to happen. Sometimes things are going to get funky. You ready? Let's try a funky one. Let me find one that's not that bad. Oh, that one's not. Oh, but you wouldn't do it that way. You know what? Let's just do that one. Okay. You ready? Spaghetti. Let's try this one. What if I gave you y equals? Yeah, we're gonna go for this one. 8x squared plus 6x plus 10. So this one, real quick, I just want to show you, if you try to factor this, say I was going to do like slide and divide, If I did 8 times 10 is 80. There aren't factors of 80 that add up to be 6. I can't solve this one by factoring. So although I love factoring, it wouldn't work in this case. But what I can do is a quad formula. I can always do the quad formula. So let's pick out A, B, and C. What is A? 8. B is 6 and C is 10. So now using my quad formula, I'll rewrite it here just so we have it right in front of us. Plus minus B squared minus 4AC all over 2A. All right, take a moment and pop in all of those pieces. We'll see if we match. There we go. So there are all of the pieces just plugged in. Yep.
Are you ever allowed to like simplify the original equation? And you have to leave it as it is? Like, could you like take a 2 out of that?
If you are solving, yes, you can.
So if you want to play the quadratic, you should just leave it as it is.
You don't have to. You should get the same thing. So if you had divided a 2 from the beginning, when you're solving, it's not going to matter. So yeah, you totally could have.
Oh,
And still done the quadratic. All right, so I'm here. Let's see what we got. A -6 plus minus. I got a 36 right there. And then, my friends, if I'm looking at this right after that B squared, I always have this like invisible box. I don't always draw it, but I know this is what I'm looking at. If I multiply those 3 numbers together, what comes out? -320, right? So look at your paper. You should have a -320 right there. The whole thing's going to be over 16. Okay, and now 36 minus 320 is, oh, thank you. All right, so now we're here. Last year, you stopped and said no solution, but now you know how to simplify a negative under a square root, right? You know how to handle this. So what I sometimes like to do, because things can get kind of messy, I sometimes just come over to the side and I'm like, hey, let me just simplify that square root sort of by itself. So if I take the square root of -284 and I'm going to break, I know I'm going to have a -1 over here. And then I'm still going to look at my list for the biggest perfect square that divides into 284. So let's take a minute. See if we can, oh, I already found it. It's 4. You want to know how I know 4 is the biggest? It's 71, right? So if I split this up and I have a 4 here and a 71 here, 71 doesn't have any of these numbers that divide in. So there are no other perfect square factors. That's the only one. So that's usually what I do. I start with any perfect square that I can find that goes in, and then just see if what's left over, does that one have a perfect square factor? Does that make sense? All right, so now I'm here and I'm like, okay, cool. Well, that's just square root of 4 is 2. And then I have that I, and then I sneak the square root of 71 on the end. So that is the square root of -284 broken down. So then I just pop back on over and then I'm like, okay, cool. So now I'm here, -6 plus minus. Instead of writing that, I'm going to write what I just found out. It simplifies to 2i root 71 all over 12. And then I ask you, is that a final answer? No. What can I do? Yeah, if I look, those 3 numbers, right? You're always looking for if all of them have a common factor, and they do, 2. So I can divide everybody by a 2.
Supposed to be over 16.
Oh, thank you. Just see if you're paying attention. Oh my gosh. Let's fix those. But lucky for us, they do still simplify, huh? There we go. Sorry about that. Good catch. All right, so my numbers 6, 2, and 16 do all still have that common factor of 2. So let's go ahead and divide by that 2. So I get a -3 plus and minus. So now that's just an I root 71 all over 8. And the good news is now you're done. You can't go any further than this because these aren't like terms, right? So I can't, like in the last example we did, I could actually add 2 and 20 together, whatever it was. These are not like terms. I can't go anywhere. That's my final answer. So where's this thing crossing the x-axis? It's not, because I have an imaginary number in my solution. So I know if I were to graph this thing, this is never, ever, ever touching the x-axis. Isn't that something? Oh. What do you think? Pretty cool, huh? Isn't it? Mm-hmm. I knew you would like this. Let me give you one more to try. And then maybe we'll stop there. And you know what? I feel like I want to make it up because all the ones on this sheet, I don't like them. I'm going to make it up. Okay, give me 1 second to find a good one, or at least a good-ish one. Let's do a, oh, I know. I'm going to put a negative there. Yeah. Two. Yes. Okay, let's try this. I don't know how it's going to come out, but I know this one does not touch the x-axis. So we'll see what happens. -2x squared plus a 5x minus 6. All right, try it. Find your ABC, pop it into that quad formula, and let's see what comes out. I'll rewrite the quad formula again, just to have it. But you try it. How are we doing so far? Want to check? I'm not done, but this is where I'm at. So where I want you to be super careful, you should have at some point under that radical, you should have a 25 minus 48. It's not a plus. You've got to be careful. You have a negative times a negative times a negative. So that's going to end up being a -48 in there. And then how do I finish this? Well, the 23 doesn't have any perfect square factors. So all I have to do is take that -1 out. So wouldn't this just become, I will do it over on the side just so you can see. If I have the negative square root of 23, all I can do, literally, the only thing I can do is break it up into the square root of 23 and the square root of -1. So this just becomes I root 23. That's the best I can do. If that thing can't factor, I just pull the I out. So now I'm here. -5 plus or minus I root 23 all over 4. And then I just got to ask myself if that's a good final answer. What do you think? Can I reduce that at all, or is that done? That, my friends, is done. That's as far as you can go. Oh, it is. Thank you. Oh, good thing it's the weekend. That's so fast. But that's it. How do we feel about this? So the only difference to what you did last year is now just tackling if this you end up with a negative under your square root. So last year you just said, oh, no solution, and you moved on. Now you're like, oh, I can just take an I out of that and I'll just, and then we have it. And then, you know, if I were then to ask you to graph this parabola, you're like, okay, cool, I can do that. I just know it's never going to cross the x-axis. Ta-da! Any questions? No, we're all right. Okay, so let me stop this because we're done with this. So